All right, here we go. Starting a new unit. We are going to be talking about translations today. So a translation moves a figure from one location to the other. The starting, where you start, is called the preimage, and then where you end is called the image. And just it's like a slide. So again, when we talk about this, translations are like sliding the image or the shape or whatever the point around. So how it kind of works is that you can move right or left with your x's. So again, if you add, you move to the right. If you subtract, you move to the left. And then for your y's, it's similar, where if you add, you go up, and if you subtract, you go down. So again, it's important to know, am I talking about the x's or am I talking about the y's? Because that's going to tell me. So in this case, x plus 4 means we're going to move to the right 4, and y minus 3 means we're going to move down 3. So I'm going to add 4 to my x's, so 2 plus 4 is 6, and I'm going to subtract 3. 6 minus 3 is 3. And if I did that one again, negative 3 plus 4 is 1, and 7 minus 3 is 4. So those would be my new coordinates if I were to use translation notation. Graph the quadrilateral ABCD and its image in prime notation. So again, you can see the difference. This is A prime. That means after my first translation. So again, I'm going to move to the right 3, and I'm going to move down 1. So negative 1 plus 3 is 2. 2 minus 1 is 1. Let's see here, 2 again, 5 minus 1 is 4, 7, 5, and 7, 1. So if I were to go through and label this, okay, here's x is 2, y is 1. I'm going to call this A prime. X is 2, y is 4. B prime. 1, 2, 3, 4, 5, 6, 7. Okay, so let's see here. That's C is 7, 1, or this is D prime. 7, 1, and then I have to go up 1, 2, 3, 4, 5, 4, C prime. So that looks to me like a trapezoid. If we work backwards, so the image xy, x plus 4 is P prime, Q prime with endpoints negative 3, 4, and Q is 2, 1. Find the coordinates of the endpoints of the preimage. So again, I'm going to work backwards. So instead of adding 4, I'm going to subtract 4, and instead of subtracting 7, I'm going to add 7, because this is already what has happened. I've already added 4 and subtracted 7. So now I need to work backwards. So if I wanted to find the original P coordinate, I would say negative 3 minus 4, that's negative 7, and 4 plus 7 is 11. And then my original Q, 2 minus 4 is negative 2, 1 plus 7 is 8. So that would be, again, my pre-image. Write a rule for the translation of triangle ABC to triangle ABC, then verify the transformation is an isometry. So if I say, all right, if I started at A, and I ended here, that means I went up 1 and left. So that's 1. Let's see here. 1, 2, 3, 4. So I went left 4. So I would say my rule for XY is that I am going to go to the left 4, and I'm going to move up 1. And so I need to check to see, hey, is that rule the same for all points? So up 1, 1, 2, 3, 4, up 1, 1, 2, 3, 4. Yes. So that's the same rule for all the points. And then again, I could go through and check my area. The area of a triangle is base times height divided by 2, which in this case, my height is 3 and my base is 1, 2, 3. So 3 times 3 divided by 2, and that's 4.5. And that's going to be the same for both triangles. Because again, translations don't affect the size. Your shapes are still congruent. Vectors, we've got our initial point, which again is like our starting point, and then the terminal point is the ending point. Your horizontal component is again how far left or right, and your vertical component is how far up or down. We write vectors, combines the horizontal and vertical components. So again, this line right here, this line FG, we would say, again, you show it's a vector with, it's like half of an arrow. So you don't fill out the other side of the arrow. You just have one side of it. And again, where do we get our component form? It's 5 units to the right, 3 units up. So that's why we write it as with these. Name the vector and write its component form. So we're going to call this, again, it starts at B, it goes through C, and that's our symbol for vector. And I'm going to say, okay, I go down 2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So write 9. So my vector in component form would be -2, 9. Over here, if I named my vector, again, starts at S, goes through T. That's the symbol for vector. Now, we do not have any vertical, okay? It is not moving vertical, so that's going to just mean that it's going to be a 0. And now I just have to determine 1, 2, 5, 6, 7, 8. So again, because it's left, it's going to be -8, and then we have 0. Because there was no vertical movement. Triangle ABC, so that's at x is 0, y is 3, x is 2, y is 4, x is 1, y is 0, and, okay, triangle. So this is my first term, and we're going to translate it. So again, looking at my vector, that means right 5, down 1. So I'm going to take each point, then it's basically like adding 5, and then I'm going to move it down 1. So let's see here, 1, 2, 3, 4, 5, down 1. Here is my new A prime. 1, 2, 3, 4, 5, down 1. Here's my new B prime, and 1, 2, 3, 4, 5, down 1 is C. There you have it. That's how you can use vectors to translate shapes as well.